generally, PC platforms are cheaper than a PLC because nowadays are very common. For example, you know that nowadays are Raspberry Pi, so a platform like this one is a single board computer cost 50, probably also less dollar or euros. So the idea is to investigate the possibility to apply and to design a PLC on such a kind of a platform. And this approach is called soft PLC. Soft means for software. Basically, a software PLC is a PC application, a software basically, which emulate the behavior of a PLC on a PC platform, a traditional PC platform. So we can, for example, run a PLC on a platform, on a very low-cost platform like a Raspberry Pi. But this approach has two main drawbacks. The first, a traditional PC platform has a number of digital input and output and analog digital and output very limited. Generally, the number of digital input and digital input and analog input on a traditional PC platform is close to zero. So the problem is using a soft PLC is not easy to interface to wiring direct sensor to this kind of platform. And the other problem is the lack of real-time behavior of a PC platform. As you probably know, when you run a PC, an application, it's working. Okay, it's working. Sorry, but I have a very high capability to break the microphone. One of the problems in a PC platform, as you know, is that it's very hard to write an application able to satisfy time requirement. When you run an application, you are not able to understand, you don't know how many time this application can take. And for industrial application, this is a very an important problem. And we can run a soft PLC application only not on traditional PC equipped with a traditional operating system, but only using a real-time operating system. Using only RTOS system, like for example, Wixworks and other operating system, we are able and we are sure that our PLC application is able to satisfy the real-time requirements. Nowadays, the technologies is rapidly changing, and nowadays it's possible to run soft PLC application not only on a single board computer, like, for example, the very well-known Raspberry Pi platform, but also on some kind of microcontroller. I don't know if you know ESP32. It's a very famous low-cost microcontroller. So basically, we can run a soft PLC on a platform that costs probably $2–3 or less. Of course, the problem is not running the PLC application on such kind of microcontroller, but the problem is the programming of this soft PLC. Fortunately, in the case of, if you are interested to testing the usage of soft PLC on low-cost platform like ESP32, you can use this open source project called OpenPLC. Basically, it's an open environment that it's the GitHub, where you can find all the source code. You can download the real-time environment emulating the soft PLC on the platform, on the ESP32, and you can download and install on your PC the free open source editor used for programming the PLC, and if I remember correctly, an open source version of a SCADA system, of a monitoring system for monitoring PLC, a complete open source environment that you can install also on your PC. The soft PLC, as mentioned before, was just the first step toward the virtualization of PLC. Nowadays, the current trend in the industrial automation is in the complete virtualization of the PLC. The idea is to run the PLC software in a container running in edge computing device. So the idea is to completely remove any hardware device, any PLC, from the automation plant. But I speak more in detail about this solution when we enter in the detail of edge computing. Just to mention here, that's the trend for the future trend for the industrial controller. But the question that probably you have, what about the robotics, the robots? Because till now, I never speak about the robots in the industrial plants. Of course, in industrial automation, nowadays, we use in industrial plants a lot of robots. Different types of robots are available in industrial automation plants. Different types, like robotic arms, cobots, the collaborative robots, autonomous mobile robots, SCADA, and so on. Each different type of robots we have in industrial plants are used for different applications. Typical applications of robotics in industrial automation are, for example, material handling, the assembly, the welding, painting, inspection, and so on. In all the applications where we need high precision, high speed, and high safety. The robots and the automation help to reduce the need of human work and help to improve the quality of the products we are producing. So your question now could be, but in the picture I showed you before, I never speak about of robots. What's the reason? Because robots, from the industrial point, from the automation industrial point of view, is viewed as a sort of machine, a tool machine, and generally the robots and the integration of robots in the industrial plants are not an easy task. So that means in the here in this in the organization I show you of the industrial plants, I never mention the robots because the robots are seen from the point of view of the industrial automation as a separate device that somehow interact at the field level with the control level, but is not controlled by the controller of the by the main controller of the plants. A robot has its own controller installed in the robotic arm, for example, we can program this controller, but generally this controller is not supervised by the rest of the supervisory system installed inside in the industrial plants. Okay. So robots are very common in industrial automation, but are hard to integrate in the pyramid I mentioned you before. So they are treated as a separate component inside in the industrial plants. Now, focus on an higher level, the SCADA, the supervisory control and data acquisition system. Basically, probably you already seen some picture like this one. The SCADA basically is the supervision system of a typical industrial plants, and it is used to provide an HMI interface to the industrial plants. As I showed you before, a PLC is not equipped with a monitor. So how we can visually give a look to the industrial plants? How if the industrial plant is working well? So the only way we have is to using the SCADA system. The SCADA system basically is a PC, an industrial PC, which task is to acquire the information from the PLC, to keep this data in a local database, and to show this information to a local operator, to a man that supervises the system. The main feature of a SCADA system is based to, for example, to keep the database and the history of the plants, to provide the interface to the operator. The operator can have a look on about the plant and if the plant is working correctly. And another important functionality of a SCADA system are the decision support system. So basically, on the data coming from the plant, the operator is able to take some decision to modify somehow some of the parameters of the plants. The SCADA system is used to manage also the maintenance, the generation of reports for the management, and so on. A SCADA system can be used also for some type of control, but generally, as I show you in the pyramid, the control functionality are generally performed only by the controller, by the PLC. The role of a SCADA is mainly to supervise this kind of controller. The SCADA system can acquire the information from the PLC using generally network interface. All the PLC I showed you before are equipped with a network interface that is used to transfer the information to the supervision system, of course. The SCADA is playing an important role in the automation because using the data stored inside in the local database is possible from an operator, a human, to improve the efficiency of the plant, to optimize the resources, and to respond to any alert or event on the industrial plants. of course, so basically the functionality of a SCADA system are to provide information about the current status of a plant, for example, the current status of the level of the water in each tank, like in this picture, to analyze the historical data and to provide information regarding alarm and events. Also, the SCADA system is nowadays, of course, is changing thanks to, of course, Industry 4.0 technologies. And for example, nowadays some of the functionality, like for example, optimization of the plants, even in the last plants are not performed again by a human operator, but by machine learning technique and artificial intelligence AI technique that automatically using the information stored in the database try to optimize best behavioral plans. Okay, so one of the current trends in the SCADA system in Industry 4.0 is the usage of cloud computing for remote transfer of these data. And one of the classical nowadays functionality of advanced SCADA system is the predictive maintenance. So again, using information about the plant, about the machine, I can understand when is the time to maintenance one of the machine of the plants. And the predictive maintenance is performed nowadays in modern SCADA system directly by AI algorithm. Just a few words also about one of the components of on the top of the industrial automation pyramids is the manufacturing execution system. The SCADA basically has the role just to monitor the system, to acquire information regarding the plants, to schedule maintenance, but the planning of the type of the production in an assembly line is defined by the manufacturing execution system, informative system. The role of this informative system is to control the production, acquiring the information from SCADA system, and to manage the resources and to plan the production of the next days. And so play an important role for the management of the entire assembly line. One step back. In order to introduce the topic on which we are interested now, the communication, basically. In the communication, in the industrial automation pyramid I showed you before, I told you that the different functionality of the automation plant are organized in level. As you can see from the picture here, generally all the equipment and devices of each level has the possibility to communicate, to exchange the information horizontally inside in the same, can exchange the information using a communication system at the same level. But in the automation system, I have also to transfer the information from one level to the other one. So you have another type of communication inside in industrial plants, a vertical communication that allows the communication and the data exchange between devices of close level. So as I mentioned you before, it's not possible for a SCADA system at supervisory level acquire directly the information from a sensor. So the communication in the vertical communication is performed only between closed layer. So the sensor at field level can exchange data with the control level, with the PLC. The PLC aggregates this information and provides the information of the sensor to the supervisory level. The SCADA system acquires the information from different controllers in the plant, aggregate this data, and provide an aggregation of this data to the planning level, to the manufacturing execution system. So from the point of view of, we can see the industrial automation plant also has a complex computer network, or better, a complex device network, communication network. We have different level of communication system in traditional industrial automation. We have the communication system used for the communication of sensors and the sensor with PLC is called field bus. It's a communication bus for the field level. The network used for the communication of data between a PLC is called control network, because connect devices at the control level. And the plant network connect the SCADA system with the PLC. Nowadays, the plant network and the control network in modern plants are the same. Another characteristic I have to highlight in this picture is that in an industrial plant, generally, we don't have a single field bus that connect, a single type of field bus connecting all the sensor and all the actuators. Because as I mentioned before, factory automation and automation and process automation basically use different devices. So if I have an industrial plant like this one, summarized in this picture, where the factory automation and process automation has to coexist in the same plants, the communication networks are different because devices are different and communication systems are different. And we, in industrial plants, that's why an industrial plant is a complex system from the communication point of view, because we have different technologies, different communication protocols that share the same space, and that somehow we need to exchange the information. For example, in this picture, I have the field bus for the factory automation and another type of field bus called IEC 61850 is a station bus for the process automation, in particular for electrical automation. And each bus has to connect different elements. So, just to summarize what I just tell you, a typical industrial automation system is an environment where the device has to share, to exchange a lot of data, and have to exchange this information generally in real time. In real time, what it means? It means that the the maximum delay, transmission delay from sensors to the PLC has to be limited and fixed. That's a specific characteristic of real-time, of field-bus industrial communication system. In a typical industrial environment, as I mentioned before, have to coexist different communication technologies. Some of them are based on Ethernet and TCP/IP. Other, like the traditional field bus, are not TCP/IP based, but use proprietary protocol. In some application, for example, in process automation, the usage of wireless communication system is possible. And so, in some application, we have also wireless communication protocol that share the same environment. But we enter more in detail about this in a couple of days. So we have in traditional industrial plants a hierarchical organization also of the communication infrastructure. So we have the communication between computer at the higher level, between MIS and SCADA, for example. And in this case, generally we use Ethernet-based communication network, or also Wi-Fi is also possible. We use generally protocols based on TCP/IP because it's a traditional communication between computers. And one of the hot topics for this kind of communication system is the cybersecurity. So that means we need to protect the network from external access, external threats, and one of the main requirements of this level is the capability of the communication system to transfer a huge amount of data. Then we have the communication between computers and controllers, basically between the SCADA and PLC. Also in this case, we can use Ethernet and TCP/IP protocols, because again, in the communication level between SCADA and PLC, we don't need to respect real-time behavior, because we are just transferring information for monitoring purposes. So we need to be able to transfer a huge amount of data without any specific requirement in terms of real-time behavior. As probably, I'm not sure if I show you in the next slide, but nowadays the communication protocol used for the communication between SCADA and controllers and PLC is the so-called OPC UA protocol that probably we see in one of our last lecture. In industrial automation, we have another level of communication, the communication between the controllers inside the cell level. Generally, the communication between controllers require advanced communication system able to satisfy some real-time requirements in the communication. The most strict communication system from the point of view of real-time communication is for sure the field bus, the lower layer of the communication. Because at this layer, field bus layer, we need to transfer the information from sensor to the controller. And if you remember the slide of a tank, the controller take its decision on how to operate on the actuator on the basis of information coming from the sensor. So any delay I have in the communication system between sensor and the controller affect the behavior and the performance of the control system loop. And in some cases, make the control law impossible to realize. So the typical response time of this kind of network is below 50 milliseconds. I enter in detail on the field bus, just this one probably is the last slide for today, to the field bus, because the field bus, as I mentioned before, are specific communication network used just and only for industrial plants. They are dedicated system which has a specific characteristic. In particular, the field bus should be simple and economic, because we need to try to reduce the cost of the installation of field bus in industrial plants, because a field bus can connect hundreds of sensors and hundreds of actuators in a real system. So it's important to reduce the cost of this communication. And since the field bus transfer the information coming from sensor, the field bus, the communication of a field bus has to be robust and reliable. Generally, it's not allowed to lost information at this level. Otherwise, the controller is not able to control the system if we miss some of the data. The problem of the industrial field bus is that during the last probably 40 years, the manufacturer of devices for industrial automation, like Siemens, Rockwell Automation, Bosch, Schneider Electric, and so on, in the last 40 years design approximately 10, 15 different type of field bus system. Each of them more or less with the same characteristics. And proprietary protocol. So that means I cannot connect one sensor produced by one manufacturer using the communication protocol of another manufacturer. This situation basically limits the interoperability between devices in industrial automation. That's why nowadays an industrial plants typically use components of only one single manufacturer, because the interoperability between sensors and controller of different manufacturers is nowadays practically impossible. The standard, because in approximately 20 years ago has been defined a standard called IEC 1158, but in this standard basically are defined all the existing communication problems. It does not solve the problem. Recently, in the last 20 years, and that's the last things for today, the situation is improving, because the traditional field bus based on serial connection moved to Ethernet-based connection. And this situation is improving the usage of TCP/IP based protocol over Ethernet inside, also at the field level, is going to improve the interoperability between devices produced by different operators. Okay, that's the last slide for today, because from the next lecture we start with the industrial Internet of Things. Okay? Thank you.